Hi everyone, I hope you all are doing good. So, in my today's session, I'm going to cover the abstract factory design pattern. So, as I have already explained, the factory design pattern, or sometimes it is also called the factory method. Okay, so in my today's session, I'm going to explain this abstract factory design pattern, which is basically a extended version, or you can say which adds more abstraction and loose coupling to our factory design pattern or factory method design pattern. Okay, so let's start with this. So according to Gang of Four definition, what is abstract factory design pattern? Okay, so it provide an interface for creating families of related or dependent objects without specifying their concrete classes. Okay, so from the statement itself, it's pretty much clear. Okay, the entire synthesis or the entire focus is on creating loosely coupled systems, guys. See the statement: provide an interface for creating families of related or dependent objects, okay, without specifying their concrete classes, which means basically we will be dealing with the abstract classes, okay, or the interfaces most of the time. So abstract factory design pattern facilitates an interface to create the set of related or dependent objects without specifying their concrete classes. Abstract factory pattern behaves as the core factory, which is responsible for creating other factories. Yeah, sometimes it's called that abstract factory pattern is called as factory of factories, basically. That's why they say AFDP, that is abstract factory design pattern, is also called as factory of factories. Okay, it is not a must to use factory pattern within abstract factory. Depending upon your requirement, you can also use builder pattern or prototype pattern to create objects within the abstract factory pattern. So basically, abstract factory, as I already said, it's a factory of factories. Okay, so it is not a hard and fast rule that you should make use of only again a factory design pattern in order to create factory, in order to create objects, okay, in order to create other products, basically. Okay, you can make use of any other design pattern which suits your requirement. It may be a prototype design pattern, or it may be a builder pattern inside a factory design pattern. Okay, so I'm going to explain what all these statements say, what they are trying to what they are trying to give a hint about this abstract factory design pattern in my programming session. Okay, so let's go through the UML diagram, or I can say class diagram. I think you won't understand at the first glance, but still I will try to explain you so that you will understand the core idea of this abstract factory design pattern UML diagram. See, your client is your main program, basically. Okay, so if you see the class hierarchy here, okay, this is your client application who basically consumes your abstract factory design pattern. Okay, so this is your client application, so no need to worry much about it. We will come to this later. So what is the first thing? Okay, what is the core purpose of a factory? The factory creates products, right? So first we have to define an abstract product. Okay, first we need to provide, we need to identify a family of related products, a family of related objects. Okay, so you abstract factory design pattern basically deals with creating a families of related objects. So for example, I'm going to explain with the example now. Okay, so let me show you. So in order to make our life easier, can you see here? Okay, so let's take an example of car is basically a product, okay, which will be sold by many international MNC companies. Okay, so let's relate our example of car and its manufacturing process with the abstract factory design pattern. Okay, so see, what is the core idea of factory? It has to create some product, right? So first of all, we have to abstract out what are those products. First, we have to come up with those abstract products, basically. Okay, so let's relate this diagram now. Abstract product A. Okay, so what I have done is I have created an abstract product car. I don't know what kind of car, what model, which company, no. But what I have done is, in order to represent this car entity, okay, I have provided some basic properties like what is its engine, what is its mileage, what is its name, basically, okay, and what are its operations. Okay, a basic car or a bare minimum car should provide all these features, guys. It should have an engine, it should be having a good mileage or mileage number, it should have a name, it should have a start operation, it should have a stop operation. This is my very core features which every car supports. Okay, so that's why I call this car as my abstract product. Let's relate this to this here. Okay, so what is my abstract product? My abstract product is car. Now what I'm going to do from this abstract product, now this is a very generalization. Okay, this is the generalization of a product what I represented in terms of this car class, okay, which is an abstract class. Now I'm going to create a specializations or the concrete classes basically. Okay. So if you see the product A2 and product A1 are basically inheriting from abstract product. Okay. Okay. So let's come to my class diagram with the example that I basically created a small example and try to understand this pattern. Okay. So what I did is now I basically specialized. Okay, I took a real-time scenario. Okay, there is a company called Maruti Suzuki, or you can call it a Suzuki company, which is from Japan. Okay, nowadays they have two outlets. Okay, one is called their Maruti Suzuki Arena outlet, and another is called the Nexa segment. Okay, where they sell their premium segment cars basically. Okay, so now their manufacturing process is little different. Okay, even if they belong to same company, the family of related objects. Okay, you can correlate this statement here. Okay, provide an interface for creating families of related or dependent objects. So basically both the cars, right, Arena car and Nexa car, they are Suzuki car only. They have many things in common, guys. They have many things in common, but they differ by some of the features. Okay, so what I did is, this is my abstract product. Okay, car. Then from that car I basically created two more abstractions. Okay, which is called a arena car and a nexa car. Okay, so these two things, right, these two things are further abstraction of this car. Okay, if I wanted, I would have put both these things in order to resemble with this UML diagram, but I have not done that because I basically purified the design further because I found some functionalities or some attributes which are common with both these car products, right? So that's why I took them and put it into one abstract base class. Okay, so that is my abstract base class, and from there I define two more class. Okay, one is arena car and one is nexa car. Again, I don't know about what model. Okay, in arena car, what all types of cars are there, what all kind of models are there. Okay, and same, what all kind of models are there in the nexa car. Okay, so again these two are abstract base classes. Guys, the option is yours. You can go with abstract classes or interfaces. It's up to you. But as abstract factory design pattern most of the time deals with abstraction, it's best practice to go with abstract classes because there will be chance that you can provide some default implementation for your operations. That's why most of the time it's preferred to go with abstract based classes. Okay, when we try to implement abstract design factory. Okay, so then we will go. Okay, now till here I had everything as my abstraction basically. Okay, till here everything was a generalization. Now I will deep dive into the specialization or the concrete products. Okay, this part, guys. Okay, till now whatever I explained, these three classes basically belong to this abstract product. Okay, where I basically segregated what is my core product and what are the very common features across all the products which are created from them. So I put them into this abstract car class. Okay, and then now I'm going to create the concrete implementation or concrete classes. So now inside this car product, okay, under arena car segment, yeah, there are many models, but for demonstration purpose I'm taking Swift and Brezza. Okay, so Swift is basically a Maruti Suzuki arena car. It comes under the arena segment. So what I have done is I have basically specialized Swift from Arena car. So the Swift class basically inherits from Arena car. And see, guys, okay, what all things it adds. Okay, engine, mileage, name, anyway coming from my abstraction. Okay, over here, anyway it is coming from abstraction. Okay, so what is the extra thing that Swift is going to provide? See, put your car into hill hold assist mode. Suppose you are driving in hill station area, and you know it will be hill station, there will be slopes basically. Okay, so in such roads, if you the moment take your legs out of your out of your brake, your car will start moving backwards. So there is one feature provided where if your car supports this hill hold assist mode, then your car won't go backside, it will stop there only. So a specialization on a basic car basically. Okay, it's a special feature only given to this Swift car. So it is giving hill hold assist, so that I have added here. So can you see the specialization? Then set cruise control. Let's assume only Swift is providing cruise control out of all other cars. So this is also one specialization Swift comes with. So I put a set cruise control operation over here. Start and stop anyway coming from your base class. Okay. So from my abstract product, I created a concrete product called Swift. Then I will go to Brisa, one more car, okay, which comes under the arena segment. Again, see this specialization. It has engine mileage name from its base, but apart from that, yeah, again, yeah, as it belongs to the same arena car, so this also provides us both hill hold assist and cruise control features. Okay, so arena segment, this arena segment car or product basically provides these two extra features, that is a hill hold assist and cruise control. Okay, now there's one more class basically called Nexa car or a Nexa segment. Okay, now let's see. There are two cars which are inheriting from Nexa. Okay, Nexa car base class. So what extra features these cars are giving? Okay, these cars also have an engine mileage name which is common from its base class. But apart from that, can you see? Okay, uh, this particular car provides initiate automatic parking. Okay, yeah, this this car provides automatic parking facility as well as automatic driving facility. Let's say some advancement has happened from Suzuki side and they are providing automatic car driving mode, so autopilot mode you can say. Okay, so you are not required to do, it's like a Tesla car. Okay, you just tell it where you want to go and it will take you automatically. So what happened with this specialization in the Nexa segment? There's a premium segment. I can see that these cars are coming with some additional features. Automatic, that is automatic drive mode and automatic parking assistant. Okay, so this is the specialization this segment of car is providing. Okay, so basically as part of abstract design factory pattern, I have basically created an abstraction of my product and then I have provided the specialization of my product also. Now someone has to create these cars, right guys? Okay, so now we will come to the part factory. Okay, the abstract factory. So let's see what our abstract factory or any factory does. Okay, if I take example of my Suzuki car or Suzuki company, okay, both Nexa and Arena segment belong to one company only. It's their product only. Okay, so abstract factory, yes, they can create Suzuki car, they can create any Brisa car. So all this belongs to the factory abstraction. Okay, so this is my abstract factory. Okay, so let's resemble with our implementation. Okay, here is abstract factory, so I call it car factory. That is my base class, and what is my factory is doing? It will create car, that's it. My factory's whole and sole purpose is it has to create a car. Okay, that is the high level abstraction. Any factory does that. Any car factory, what is their main goal? They have to create a car, that's it, right? So that's why I abstract out my car factory as a base class or abstract base class, you can say. Then I will start creating specialization, the Nexa car factory, in order to create my Nexa car products. Same way, I will create Suzuki Arena car factory in order to create my Suzuki's Arena segment car products. Are you understanding, guys? How we are how we are so cleanly, loosely coupling this system. Okay, we have divided our products, we have divided our factory classes, and then we have a client application separate. Okay, and in the end all will connect with each other and they work together in order to provide a loosely coupled system. Okay, so I created my Nexa car factory and it will create a car. Okay, and also my Arena car factory which will create a car for Arena segment. But how it will come to know I have to create Arena car only, and how Nexa car factory will come to know it has to create Nexa car only, I'm going to explain that particular magic in few moments with the exercise, guys. So give me some time. Okay. So let me switch to my Visual Studio. So yeah, so for the sake of saving time, I have typed the program, but anyway, I'm going to explain line by line. Don't worry. So can you see I have created some named constants or also called enumeration, I think available in many programming languages. So public enum car manufacturer. Okay, what are the two manufacturers basically? Okay, one is the Suzuki Arena and one is Nexa. Okay, even if they belong to same company, okay, they are the two different cars being manufactured by two different companies, guys, basically. Okay, so take it as an example. So car manufacturer, yes, I have two manufacturers, Suzuki Arena and Nexa. Then car model. What are the various models of car I have to create? Yeah, under this particular car manufacturers for both Suzuki Arena and Nexa, yeah, Baleno I can create, Brezza I can create, Swift I can create, and Grand Vitara car I can create. Okay, so then comes abstraction of my car. As I explained in my UML diagram, see, public abstract class car, it has name, engine, mileage, and bare minimum function of start and stop. Okay. Then comes the another abstract class arena car, which inherits from car with these all basic attributes, and then it will provide the specialization of setting cruise control and putting your vehicle into hill hold assist mode. These are the two extra feature this arena car is providing. Same way, now I will create one more abstract class which is called Nexa car, which inherits from the base class car with all basic attributes or base features, and then it will add extra features like set auto drive and initiate automatic parking, as already explained. So this is the class abstract class for my Nexa car. Okay, still I'm in abstraction. Okay, still I'm in abstraction, there is no concrete implementation. Okay, so now one more abstraction. This is till now whatever I explained, it was for the product abstraction in abstract design factory pattern. Now the factory abstraction. So I have a base class called car factory, which basically returns a car. Can you see the base class car with the bare minimum features? Okay, so car factory, which basically returns a car when you call the method create car and you pass the model. And if you see the model, basically I have these are the supported models with me for the time being. Okay, so car factory, very simple operation. It will create a car, okay, based on the requirement, or sorry, based on the input you have provided, that is based on your requirement of model. That's it. So that's the abstract car factory. Now same thing I had did for Baleno, that is an Nexa car also, guys, same thing. Okay, it will also contain all these details, name, engine, mileage, and yeah, the concrete implementation will start from here, that I forgot to mention. Okay, for the product, basically for this car products. Okay, till here I was in abstraction. Okay, arena car, Nexa car, all were the abstractions, but now here I am providing a concrete implementation. So public class Baleno, if you see, it is inheriting from Nexa car because Baleno is a Nexa segment model, or it comes under Nexa car. Okay, so that's why it inherits from Nexa car. And yes, it provides initiate automatic car parking facility and automatic drive facility. Okay, so these are the two features. So this is the concrete implementation. When you do this, basically this operation will happen, which I have achieved through a simple console.writeline, that is printing a small statement on your screen. Okay, so that's it. Cruise control, same. And same again, I will go to Brezza and I will inherit from Arena car because Brezza belongs to Arena segment. So here you will get hill hold assist and cruise control features. Okay, so same for Swift also, which I have provided the concrete implementation basically. So well, once all this thing is done, now I'm going for the concrete implementation of my factory. Okay, that is from car factory. As I already explained, I have two manufacturers, Suzuki Arena and Nexa. Okay, so I have to provide a concrete factory, right? Just on abstraction, nothing will work. Okay, so when I go to the car factory, that is the Suzuki Arena car factory, basically I'm inheriting from car factory, which provides the bare minimum feature, oh sorry, bare minimum method, which is called, or operation, which is called create car. Okay, now under Suzuki Arena car factory, I'm basically overriding the base class version method create car. Okay, so what I'm doing here, I'm basically providing a concrete implementation. What should happen when you receive a model? Okay, so if you receive a car model of Swift, then I will create a Swift car. Okay, if you pass me a model of Brezza, okay, then I will create a model of Brezza car basically. Okay, only two are supported, so that's what I'm doing. If it doesn't belong to any one of these, then I don't do anything. I will return a null. No boss, apart from these two I don't know anything, so that's what I'm returning, a null. Well, that is said, same applies for the Nexa car factory. Here I will receive the model, and here can you see, okay, both Grand Vitara and Baleno comes into Nexa segment or Nexa car factory. So if the model, if you are requesting for a Grand Vitara car, I will create a Grand Vitara car and I will return it to you. If you are requesting me a Baleno car, if as a customer, if I request for a Baleno car, then I will create a Baleno car and return it to you. Okay. Well, all these things are said. Now comes the client application or the consumer application, you can call internal class car client. Okay. So see how it works. Okay. First of all, I will read from the user. Okay. See, for example, a customer is okay, coming in, walking in into my car showroom, and yes, definitely he will come with a requirement of purchasing a car. So first thing what I will ask, okay, okay boss, these are the two options, what car manufacturer you want. We have both segments. We have a Suzuki Arena as a separate company, okay, and also we have an Nexa as also a separate company. Okay, out of these two segment, which car you want? Okay, then if he says one Suzuki Arena, can you see what is going to happen if the manufacturer choice, okay, if the manufacturer choice is equal to 1, then what I'm going to do is I will create a factory of Suzuki Arena car factory. Can you see here? Create a new Suzuki Arena car factory, and then I will read a model from him. What model you want? Okay, Swift or Brezza? Okay, so based on his model requirement, what I'm going to do is simply I'm going to create a car. Okay, so if he wants Swift, that is if the choice is equal to 1, we will create Swift car, otherwise we will create Brezza car. Okay, then once the car has been created, basically you can verify its functionality. You can start, you can put it into, it's like taking a test drive. Okay, you went to a showroom and you are taking test drive. You are starting the car, you are trying the cruise control feature, you are trying the hill hold assist feature, and once everything is done, once you are satisfied with it, you go back to your showroom and you will stop your car. Okay, so a very trivial example basically, but still it will help you to understand this abstract base class factory design pattern, guys. Okay, so one more thing I would like to explain here is that even the creation of this car factory can also be abstracted out. So here, instead of directly using this new car factory basically, what I can do is basically I can make use of the design factory method. Okay, as I explained in my previous session, there is one more design pattern which is called design factory, sorry, what is that? Yeah, factory design method or factory design pattern. Okay, so what it does basically, what I have to do is very simple. Let me quickly show you here itself. Okay, I will say public, say public class. I will public class, I will call it, okay, say car factory. Okay, public class, car factory provider, I can say. Okay, so what I'm going to do is very simple steps I'm going to take, very simple. So I will provide a method here. Okay, public. Let's call it sorry, car factory. I can say car factory base class, car factory. So I got get factory, and here simply I will pass out my manufacturer. Yeah, the manufacturer type basically the car manufacturer type. So if I take this and pass over here, let me complete this small change. So I'm done with the small modification now. See, the whole and sole idea of abstract design factory pattern. Okay, the abstract design factory pattern is that Where am I? Yeah, the abstract factory design pattern is that you should never make use of the concrete classes directly in your client application. Okay, you should never make use of your concrete class names directly using the new operator. Okay, so if you see the client application, see my client application is nowhere referring directly to any concrete classes. Okay, one change I did, what I did is I basically created one more factory provider, or you can call it as a factory method design pattern, which I simply use to get the required factory for my implementation. Okay, so if you see here, what happens is when I want a Nexa car needs to be created, first what I'm going to do from the car factory provider, I will call the get factory method and I will pass my requirement of factory as Nexa. So it will return me a Nexa car factory. And if you see the return type, it is a car factory. It is your abstract base class. Can you see this, guys? I am nowhere referring to the concrete implementations. If you see, this is being used by these two concrete classes, but you can't see anywhere I'm making use of these concrete class names in my client application. Okay, this basically enables the loosely coupling in your systems. Tomorrow, even if you come with n number of cars and n number of segments like this, if you go here, if tomorrow you come up with n number of car factories, today it is Suzuki Arena factory, Nexa in a factory, tomorrow it comes Toyota car factory, tomorrow it comes BMW car factory. Okay, you are not required to do any code changes in your client application. Your client application will remain untouched because it always deals with your abstract interfaces or abstract base classes. Okay, so that is the advantage of using abstract factory design pattern, guys. Okay, so very simple. So I will get by passing my model, that is what I want. Okay, I want an Exa model, so I will get my factory. So basically a simple implementation, what it does, get factory, you pass the type. If it is Nexa, here you will basically create that factory and return it to your client application. That's it. So no need of directly using new operator in your main method, okay, or in your client application. So you have loosely coupled the implementation. Okay. Same applies for the car model. When you choose a car model, we will pass the car model. And if you see, the car factory will basically return that car for you. Okay. So in my case, it is Nexa. If I go to Nexa, can you see? If I pass Grand Vitara, it will return Grand Vitara. If it is Baleno, it will return a Baleno car. Again, these two concrete classes you will never find in your client applications. No, okay, this is how abstract design factory abstract factory design pattern works basically. Okay, so everything is loosely coupled. Okay, nothing is directly pointing to anything, no hard coded references, everything happens on in an isolated manner or in a loosely coupled manner, I can say. So let's run this application. So please select the car manufacturer. Okay, so what I'm going to select, I will press say one, I want to go with the Suzuki Arena segment. Okay, under Suzuki Arena, what you want to select? What car I want? Okay, they are asking me. So I would like to go with Swift. I will press one and I'll say, can you see, guys? Starting Swift 2023. Okay, they have now the implementation basically created a Swift car, and now I'm basically invoking the operations on that Swift car. That is starting the Swift car. Swift is in cruise control with speed 80 km per hour. Car is in hill assist mode, and then I'm stopping the car. So very simple. Okay, guys. So this is how this particular abstract factory design pattern works. Okay. So let me go back to my PDF, and here now we will discuss the advantages. The advantages of abstract factory. See, abstract factory pattern allows loose coupling, which I have already explained. You won't be having any hard-coded concrete class references in your client application. Your client application will always deal with the abstract base classes or interfaces if you have used interfaces in case of abstract base classes. If you see this return type, car factory is basically an abstract base class. Okay, if you see here, see it's abstract base class. Okay, so most of the time you will be dealing with the abstract base class reference variables. So this is abstract base class reference variable. Okay, and then when you create a car also, right, see, can you see, you are not directly returning the concrete car, that is Swift, Suzuki, Baleno. No, you are simply returning the abstract base class. You are basically your return type will always be abstract base class or an interface if you are making use of interfaces. Okay. Okay. One thing I would like to explain, because I have used the generalization at the two step. Can you see here? Nexa car. So if you see here, even my Nexa car is not a concrete car, guys. It's a base class only. If you see abstract, see public abstract class, Nexa car inherits from car with these additional two features. How we implement, it's up to the concrete method. Okay. The concrete classes basically how they are going to implement. But the Nexa segment car is going to provide these two features. That's what I will come to know from this abstract base class. Okay. That's why if I want to access these two features of my Nexa car, I have to do a typecast over here. That's why I did a Nexa car typecast. Again, Nexa car is not my concrete implementation. That's why I am allowed to make use of this abstract class casting in order to access these two functionalities of that Nexa segment car. Same applies for Arena car. In case of Arena car, actually, my Arena car factory will always return a car object only. Okay, the car reference variable only. But if I want to access the specialization which has been provided in Arena car, I have to do a typecast and then I have to access set cruise control and put hold assist mode. Okay, because if you remove this typecast, can you see? It complains that car does not contain a definition for set cruise control and a no accessible extension method set cruise control. You got it, because if you go to the definition of car, car provides the bare minimum features. Okay, so all the bare minimum features of name, engine, mileage, start, stop, all these things you can invoke on this car abstract class reference variable, but you can't access these two because these two have been defined on the abstract class arena car, which further inherits from car and it is abstract in nature. So in order to access these two features, you have to do a typecast to arena car. And now in the context of abstract abstract factory design pattern, both my arena car and nexa cars also are also the abstractions. They are abstract products, so I am allowed to make use them in order to typecast and access those features or functionalities. Okay, so I hope you people understood the notion of abstract factory design pattern. Okay, uh, this is really a good approach when you are dealing with the families of related objects, guys. And yeah, this is the point where you can apply this design pattern. Okay, so abstract factory pattern allows loose coupling, allows object creation till runtime with the use of interface and an abstract class. Okay, as I already explained, you are not required to create the object instantly. Okay, your object creation will go till runtime. Okay, based on the input you pass, and that input will be read, and based on that input's value your objects will be created. Okay, and again, you will never receive or you will never reference the exact concrete class. Okay, always you will deal with the interface or abstract class reference variables. Okay, new factories can be easily added without changing the client implementation, which I already explained. Okay, this will remain untouched, guys, even if I introduce a new factory like this. Okay, so if I go to, this is my Suzuki Arena factory, this is my Nexa factory. So tomorrow if a requirement comes that I want to integrate Toyota also in my system, it's very simple. Public class Toyota, Toyota. Okay, so that's it. Toyota factory, I can say, and I will inherit from my car factory. That's it, simple. Nothing will remain untouched. Okay, nothing will be untouched in my client application. Okay, only thing I have to keep on adding new factory classes and new products whenever a new company or new car has been introduced into my system. As simple as it is. Okay, so that's what I wanted to explain. And this point basically emphasizes on that new factories can be easily added without changing the client application. An existing factory can be modified without changing the client code. Agreed, because you are not at all referencing to any of the concrete classes. All your operations are happening on the basis of contracts. Basically, these are all contracts you have specified. What should be my car? Okay, and what should be my Nexa car basically, what should be my Arena car basically, and then you are also specifying a contract for your factory also, which is something like this. Yeah. So what should be my factory? This is also a contract. Yes, my factory should be a car factory. It should return a car and it should return a car model as an input parameter. That's it. So inside implementation, whatever you change, okay, it will never hamper your client application. Okay, so do remember this point. Whenever a new factory comes, you will introduce a new factory class basically. Okay, new car factory as I shown in the previous example, and you will implement that factory related implementation in its concrete implementation of create car. Okay guys, so like this it will go. So tomorrow if Toyota comes, what I'm going to do, just to copy paste this part, I will paste over here, and here car model I will introduce say Glanza. Okay, and I will return a Glanza car object. Okay, just for the demonstration purpose I'm showing it. That's it, a simple change. Every time a new requirement comes, the requirement will be implemented in terms of a new class, applies for both the factory as well as its products. Okay, so same the way how I created a public class Swift inheriting from Arena car or something, in the case of Toyota I will straight away inherit from Toyota and I will provide the implementation. Okay, very simple. So that's all about an existing factory can be modified without changing the client's code. Okay, there are some disadvantages basically. Let's see what are the disadvantages. Lots of interfaces and classes are introduced along with the pattern implementation. This can introduce code complexity. Agreed. Agreed. Okay, the flexibility of adding a new functionality to your application basically also introduces a complexity in terms of a n number of classes. Okay, so if I go to the UML diagram, okay, let's take the example of this. Today I have, okay, Arena car and Nexa car, and today I have Nexa car factory and Suzuki Arena car factory. Okay, product level two classes, factory level two classes. If Toyota comes into picture, one more class will come, Toyota car factory, and then one more one more concrete class will comes into picture. Okay, one more one more concrete class will comes into picture if there is only one car, or it depends on a number of cars they support. Okay, and also you also need to specify one more abstract base class which is called Toyota car, okay, which provides the bare minimum features that a Toyota car provides. And from that abstract Toyota car class, you are going to provide a specialization for n number of Toyota car products. Toyota has Glanza, Highrider, Urban Cruiser, okay, Fortuner, n number of cars are there, right? So basically, your classes will grow. What I can say, your classes will grow. mm, Exponentially I can say, okay, exponentially. So that is the problem or a disadvantage with this particular design pattern. Okay, the pattern is applicable to only families of related objects. Yes, always remember. Okay, if if you want to make use of abstract factory design pattern, it should be used for the family of related objects. For example, car. Okay, a car can be Toyota, Suzuki, BMW, Volkswagen, whatever, but they all belong to a same category of cars. Okay, you can't use them for some other products basically. Okay, you can't use the same implementation for some other product like laptops. No, they are two separate things, right? A laptop is a separate thing, a car is a separate thing, right? So it should always belong to a family of related objects. Okay, car, so all kind of cars. Okay, it may be a bus also, you can include a bus also, not a issue, because that also belongs to a vehicle category itself. Okay, but you can't include other products like laptops, appliances, home appliances. No, that won't work. Reduces code readability due to the level of abstraction it introduces. Yes, sometimes it's very difficult to understand. Okay, uh, or it is difficult to read out the code itself. See, I had only two car manufacturers, okay, and that yielded such a small UML diagram or class diagram. Just imagine if you have say 15 or 50 car manufacturers, and each manufacturer is supporting 10 to 15 car models. Trust me guys, you you won't make out what is happening with the UML diagram. So that is the complexity, or it will create a issue with readability when the level of abstraction keep on increasing. Okay, but in spite of that, I think abstract factory design pattern is the best approach when we want to deal with the families of related objects. Okay, so this can be used, for example, this can be used in our GUI creation, basically GUI component creation. Take an example. You have to create a button. You have to render a button on a screen. Okay. And that button creation depends on the underlying operating system. Its underlying operating system is Windows operating system, then create a Windows button. If it is a Mac OS, then create a visual representation for the Mac OS operating system. So when you find these kind of scenarios, right, only in such scenarios you have to make use of this abstract factory design pattern. Okay, guys. So I hope you people understood this with this tiny example. Okay. Thank you for listening and have a nice day.